Hello once again. This is Bruce Howard, and I have a new demonstration I wanted to use with a floating compass, just to show a couple principles of the magnetic field, the subatomic particles that make up that field. One demonstration I'll do is this is a long magnet here with some neodymiums, some regular ones at the end. I just did this to extend the field in a longer shape. So here, I'll just start like this. As I go here to the poles, you'll see it flip. As I go back over here, it'll flip, meaning that the field is rotating as it is moving around the magnet. Here you'll see it tilt over towards the poles. There, see? Back. Now I'm going to do the north-south alignment and showing how in the center of this magnet the field or the particles will flip over. Now as I move it down, right in the middle, see this? Right here is where I'm talking about where the block wall is. It goes back, forth. So there's a change in direction right in the center. The particles are aligned one way and then they flip and go the other way. Now I agree that the field on the very outside is moving in a straight line or in a curved path from north to south. And as it does that in the center, it flips its direction. But if you look at a magnet with filings, you will see something maybe you did not notice. Hello again, Howard Bruce. Just continue on from the thing with compass and the field, showing how it changes in the center. I've done a different display this time with magnets, neodymium, the dollar magnet. As you can see, it wants to be in the center here. So to demonstrate this effect, we'll start it rotating through the center as I showed you before. This is where it naturally wants to travel. Now, I agree that the magnetic field does move from north to south on the outside, but as I showed with the compass, as it moves, it will flip its direction here and continue on the very outside fringes where it's very loosely held by the field. But if you look at iron filings from any magnet, look at it closely, you will see along the sides the field goes straight out. Not along, but you can see it heading straight out of the magnet all the way down the side here. Now, if you hold the magnet up to a television set, you will also see a butterfly effect. You will have 4 quadrants. 1, 2, 3, 4. So my theory is that the field itself travels in 2 different ways. It's sort of combined as a double helix almost, traveling this way, this way, this way, and this way. Right in the center is where that sweet spot is, and this is where I theorize the actual energy being extracted from outside, the ether or whatever you call it, is moving through, and the concentrated forces are on the end. They show the most because they're isolated north or south, whereas the center forces are balanced, so you get a lot of force, but it's not too measurable because opposite and equal forces cancel each other out. Okay, so let's just show you here what I'm talking about. Once again, a little sweet spot where the subatomic particles are moving together and with spin, as all particles, subatomic particles do. But this is the difference. When I tilt the magnet slightly, you see it go from side to side in an arch. This is the natural pathway that these particles want to take. And if I tilt it a bit more, You can see he wants to come back here. Also, it goes the other way as well. Now just trying to get a little inertia going here. There we go. So we'll take this path to the center. That's where it wants to be, right there. Gets a little kick in there, and then it just heads out. Same with the other direction. If I now tilt the magnets the other way, I get the opposite effect. Now they're traveling in the other direction. Well, let's come all the way back up, sort of didn't do there, but I'll get a little bit of speed down here. There we go. Alright. So, this is what I refer to with the magnetic field traveling one way or the other. Hope you enjoyed this demonstration. Look forward to any comments, questions. Hope some more experimenters, researchers out there want to try some of this stuff. See what they can come up with. Thank you. Signing off.